Alright guys, welcome back to Underground Science, and in this video, it's going to be kind of a continuation in an idea when we talk about, or a continuation of my previous video about a simple reflex arc. We're going to be talking about a polysynaptic reflex arc versus a monosynaptic reflex arc. Alright, and it sounds weird, but it's not that. It's pretty easy, alright? So let's do this, okay? So let's just talk about this. So a monosynaptic reflex arc is what it says. All right, so a monosynaptic, let's go and write this down before we see it like in a drawing. A monosynaptic reflex arc, all right, is what it says it is. It's a monosynaptic reflex arc. Mono meaning one, synaptic meaning one synapse. Like monosynaptic means one synapse, all right? There's only one synapse involved in that particular, in this particular reflex arc, all right? That's all it means. So just one synapse involved in our reflex arc, whatever reflex arc we're talking about, all right? So one synapse involved in reflex arc. And then if you guys follow this definition, right, you guys probably already guessed it, that a polysynaptic reflex arc means that we have a reflex arc that involves more than one synapse. All right, so a polysynaptic reflex arc involves more than one synapse. All right, because poly means more than, or poly means many, right? And if we involve both of these words, polysynaptic, right, that means more than one reflex arc. All right, so in total, this means that we have a reflex arc that involves more than one synapse. All right, so that's pretty much it. So that involves more than one. All right, sorry about that. Let me write that neater. That involves more than one synapse. All right, so if we go and look at a drawing of that, it's pretty much going to be the same. So a monosynaptic reflex arc, right? So make sure to go and check out my simple reflex arc video where I talked about the drawing in more detail. So let's say we have a lot of dendrites here. This is our afferent neuron. Then we have our axon projecting out. Actually, you know what? Let me just draw in the zoomed in version, because in the simple reflex arc video it got way too crowded. So we have our dendrites right here of our afferent neuron. And then we have our axon projecting down into our gray matter of our spinal cord. In particular, this is going to be in the dorsal part of our spinal cord, right? Because our afferent neuron synapses, it comes in through the posterior part of the gray matter of the spinal cord. So let's go and write that. So it comes in into our posterior or dorsal section of our gray matter of our spinal cord. All right, so that's that, and then we'll see that right now. So this is where we're going to be at this moment. We're talking about a polysynaptic reflex arc. Okay, so it's going to come here, synapse, and then we're going to have an interneuron that picks up these signals from the afferent neuron, comes here, drops those signals off via its synapse, an axon terminal and synaptic cleft, right? It's vesicles with neurotransmitters. Then we have our awesome motor neuron ready to do its job, right? Picks up those signals dropped off by the interneurons, right? By the interneuron. Then we have our axon hillock and our axon projecting out right here, and it starts going back. And let's go and draw the soma, or the cell body, right? And then so our axon again projects. We have axial potential traveling back, and we can either, in this case, let's just say we terminate on a skeletal muscle and tell that skeletal muscle to contract or something to move back, all right? Because it's a reflex. And so that's the basic reflex arc, right? And forgot to draw one important thing. Our pseudo-unipolar neuron is not finished. Remember, in our afferent neuron, we have our soma, or cell body, and our dorsal root ganglion region. And what that means is that our soma or cell body is near the dorsal part of our gray matter of our spinal cord, all right? It's not inside the gray matter. As you can see, it's outside of the gray matter. The gray matter is over here of the spinal cord, but the soma, or the cell body of the afferent neuron, is actually projected outside of the gray matter of the spinal cord. It's still near the posterior part of the spinal cord, but we call it in the region of our dorsal root ganglion, all right? So this is our soma. All right, and so that's pretty much that. And this is, you can identify this as a polysynaptic reflex arc because, first of all, this is a reflex arc. And second of all, it has more than one synapse. We have one synapse here, and we have one synapse here. So as soon as you see this, you should know that this is a polysynaptic reflex arc. So this is a polysynaptic reflex arc. All right, so let's go ahead. I bet you guys already guessed it, but let's go and look at a monosynaptic reflex arc. All right, so let me go and pull up a new picture of my sketch. All right, so let's go to new page, and let's go and pull up a new picture. All right, there you go. So now let's look at a, oh crap, sorry. Let's look at a monosynaptic reflex arc. All right, let's just get this color and just keep it consistent, right? All right, so let's look at a monosynaptic reflex arc now. So the same thing, we have our dendrites of our afferent pseudo-unipolar neuron. And then we have no soma right now because it's in our dorsal root ganglion area. Right here, we have our soma, our cell body of our afferent neuron. Then our axon continues. And actually, you know what? Same mistake again. Let's go and draw this in the zoomed in version. So it comes right here, terminates here, but this time we don't see an interneuron because our simple reflex arc doesn't have to have an interneuron. All right, so, okay, wait a minute. Let's draw our soma, very important. Our cell body of our pseudo-unipolar neuron. And what's going to happen is we're going to straight up pick up the signals via a motor neuron. So we have our dendrites of our motor neuron, and we have our cell body of our motor neuron. Remember, that's cell body and dendrites of our motor neuron is inside the gray matter of the spinal cord. Then we're going to have our axon projecting out. And it's going to go back to that muscle or whatever, right? To either to contract the skeletal muscle or another target cell, whatever it may be. And whatever the job may be, and we're going to do it. So in this case, if we say skeletal muscle, it's going to try to contract the skeletal muscle and provide a reflex so we move back if we touch something sharp or something. All right? And so that's right here, we can tell that we only have one synapse here, guys. All right, so we only have one synapse here. Just look at the number of synaptic clefts we have. We only have one synapse, which means that this drawing or this illustration represents a monosynaptic reflex arc. All right, so that's all. That's the pretty much the basic definitions of a monosynaptic reflex arc and a polysynaptic reflex arc. All right, so just remember that we're going to have some stimulus here, right? We're going to have some stimulus here, some amount of summation. Remember in our graded potentials video, right? We're going to have temporal summation or spatial summation, enough to hit that threshold potential, right, via stimulus, and then we're going to have an active potential travel, and then we're going to get the rest of the activity done via a reflex arc. All right, so that's polysynaptic and monosynaptic reflex arcs. I hope that video made sense to you guys. I really hope you guys tune into my future videos where I'll talk about more cool topics about biochem, physics, and chem. And I hope you guys hit that notification bell and like and subscribe, and see you guys later, and stay safe.